3 points are given to us and we have to find the equation of a plane passing through 3 given points. Now, equation of a plane passing through 3 given points is given by, we have already done this concept. Okay. Now, equation of a plane passing through three non-collinear points. Three non-collinear points, say x1, y1, z1, x2, y2, z2 and x3, y3, z3. Is given by, it is x minus x1, y minus y1 and z minus z1. Then x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1 and z3 minus z1. Now, when we are solving this determinant, we are getting the equation of a plane. Now, let us solve this part now. Given points are, now given points are minus 6, 3, 2, 3, minus 2, 4 and 5, 7, 3. Now, we are getting now x minus minus 6, y minus 3, z minus 2, then x2 minus x1. Now, 3 minus minus 6, negative of 2, negative of 3, 4 minus 2. Then 5 minus minus 6, 7 minus 3 and 3 minus 2, this is equal to 0. So, we are having x plus 6, then y minus 3 and z minus 2. Then 3 plus 6 minus 5 and 2, 11, 4 and 1, this is equal to 0. Now, let us evaluate it now. Expanding along R1, x plus 6 with minus 5 minus 8 minus y minus 3 with 9 minus 22 plus z minus 2 with 36 plus 55 is equal to 0. Now, x plus 6 with negative of 13 minus y minus 3 with negative of 13 plus z minus 2 with 91 is equal to 0. No. Negative of 13 x plus 6 plus positive of 13 y minus 3 plus 91 with z minus 2 is equal to 0. 78 plus 13y minus 39 plus 91z minus 182 is equal to 0. Now, negative of 13x plus 13y plus 91z negative of 182, all are negative. So negative of 299 is equal to 0, or this can be written x minus y minus 7z plus 23 is equal to 0. Hence, required equation of plane is x minus y minus 7z plus 23 is equal to 0. This is the answer.